All right, good afternoon, everyone. My name is Alona, and I'm the host for today. So, we're going to talk today about AppSec threats deserve their own incident response plan. And our speaker for today is the of um, head of research for Enzo Security, and his name is Omer Yaron. So, over to you, Omer.
Yeah. Hi, so I've just shared my slides with you. I also want to mention that in the last few months, we have been acquired Enzo by Sneak, so now we are part of Sneak. Um, yeah, but this relates to an research that I performed at Enzo. So Um, basically, I'm going to try and persuade you or convince you that one of the main things that you should be doing if you're managing a security team or application security team is probably take a look at your incident response plan for the supply chain, because this is basically the biggest growing attack surface currently today, and there are a lot of small things that you would probably want to do today and not on the day that you have an incident, and because a lot of the field of supply chain in open source especially is a bit confusing and a bit filled with terminology that is just recently been added, and it could be under stress or too much to handle, and there's a lot of things that you can do to prepare for that. And part of the things that we encountered that drove us to this research was the fact that a lot of customers were coming to us with questions that we thought they should have known their answers like by themselves before. Okay, so I'm Omer, senior security engineer at Sneak. I previously was the head of research at Enzo Security, and previous to that, I was doing quite a lot of incident response and forensics in that regard. And later, I had the privilege for working at Wix.com and had a lot of kind of two-sided view of attacks and what a company looks like during routine. Okay, so looking at the agenda, so I'm going to go over it. I'm not going to spend so much time explaining it here. So first, a bit about the attack vector of the supply chain. So I like to go over historically a bit what AppSec is or were in the past and what it is today. And historically, I think that application security was generally the domain that used to protect a deployed application, meaning that you go into every part of its development lifecycle from the beginning to end. This is like the secure development lifecycle, and then you perform operations during that time, and then there is a PT usually that is performed over the deployed application. It could be on a demo environment, a QA environment, whatever. And the supply chain in all of those kind of risks was mitigated by a static build of materials, a BOM file, which in recent years we hear more and more about it, including like the Biden order that is recently came into effect of that specifies specifically which specific fields and contractor needs to require to have a bill of material. So this was again what we did historically with application security, and the IT security was very much in the realms and responsibilities of all the developer workstations for incident response, like EDR tools and tools like that, or antiviruses and all that, of course, updates. And also servers, like server stations and servers in generally was incident response was the IT kind of realm, and they were the one that would require everything to be updated in terms of workstations and server. Okay, so that's how historically it has been looked like, the realm of application security looked like. And then in the recent years, with the introduction of agile, shift left development, DevOps, and agile development, and all of that changes that brought a lot of productivity capabilities to applications, and also shifted the way application security kind of what was under its realm, and what it needs to address these days kind of grew over IT at times, IT security. So we're talking, changes all are written here. We will focus a lot about CI and CD pipelines, and mostly, right, the continuous integration. So every time a new change is introduced, it can be automatically integrated and built, and that means a lot of things. But also generally, like, a lot of applicative handlers for infrastructure. So a lot of the infrastructure has moved into code-based, right? Infrastructure as code, and in the hands of a developer, basically. Okay. And so now it constitutes as part of the application stack. We see it as part of the application stack. And so this is to create a lot of challenges for application security incident response, because it make it a lot whole, and a lot more kind of ways to understand it. We used to look at logs and see what was the third party like doing, what was his vulnerabilities, but now it's a lot more than vulnerability management, because there's also an attack surface that actively use open source as a vector to get into to infiltrate an organization. So a bit about the software bill of material. So again, this is the concept that what's the problem? If we take our code, run it through one of the tools like Cyclone DX, which is a well-maintained tool, and it will go into all of that digestion, and in the end, we'll have a full list of all the ingredients, third-party ingredients of that software, and then tomorrow there will be like a log4j, right, kind of issue, and we all be able to look at that file and say, okay, here we have it, or we don't have it, and we have it here and here and in this version, and so on. But apparently this doesn't really work, and it doesn't work as well as it should work, and a lot of organizations could not easily answer that questions, do we have it or not? And so we set out to see what's missing. And write a bit of context, and these are a few incidents and events relating to SBOM across a Google trends timeline of searches. And we can see like it's raised over the last couple of years, grown significantly. And I added here ESLint scope incident, which is the first incident that I encountered in like real time, that we started to think, what are we doing? How should we, like as a company, I was working at a company at the time as a security, application security professional, and then we needed to come up with answers for R&D to say, are we under any threat or not? This was an event that someone hijacked a very popular package, sub-package of ESLint, which is a very popular linting for JavaScript, npm based, and then we go all the way to the log4shell, log4j incident of December 2021, where a lot of people were looking and trying to get a sense of what is the software bill of materials look like. Okay, so here is an example of how an SBOM is created. This is cdxgen, the index.js file from GitHub, and this is how an SBOM is created for Python files. And we can see that the instructions for the function to create the Python BOM is actually looking for files that are either a folder with the name poetry lock or requirements.txt under any folder, or some folder that is named requirements and there's a file named .txt. Okay, so it looks pretty simple, right? You look for pip files for poetry files, and you try to list all of those ingredients in the requirements. But when you look at the requirements.txt, right, the requirements file format, you see that requirements.txt is usually what these files are named, although this is not a requirement. So any organization could, or any convention could go and say, I don't use requirements.txt, I use some other file name by whatever, the project name, or requirements-project name, requirements-environment name, like requirements QA, requirements prod, requirements, I don't know, stage. And then the SBOM generation would just kind of oversee it. It would be in its blind spot because of the way that it works. It goes over files, and it can't, look over all of the content of all the files. It's not it's a CLI tool that runs over file path, so it has to have some kind of check for file names. So this is just an example. Of course, it goes over all of a range of basically any other technology for supply, like open source registries, you name it, Ruby gems, Go, some files, or any technology basically does that in some way, relies on file names. So this is one thing that we see, and we thought, like, okay, there's a lot that can be missed, and what are we actually looking for in an SBOM, where we're trying to find a descriptive way to describe all the open source components and all the things that comprise an application in context, and not losing, not missing on anything, and also making it more not like a permanent kind of a snapshot of an application, but a living, updated, kind of always changing, always keeping track of new changes that introduce into a modern application, which again always has integration tests and always keeps like rapidly changing. So we wrote a bunch of stuff, and we started and we checked which of those things we can get automatically and not. What can each organization can do by itself, and kind of put in his own customization, his own business logic, his own uniqueness in a way into his applications, right? Into the metadata representation of an application. So jumping back to the, I'll soon like show a bit of what we come up with, but looking just from the attacker perspective. So this is obviously, I think no one would think otherwise, that this is the fastest growing attack surface. there's a lot of public data to harvest. All of those registries are public. You can easily list all of the most like downloaded dependencies for each technologies. And aside from that, you can also list a lot of other interesting data, like which has the most maintainers, which has the most, which is updated frequently, which is of the public Git associated repositories have, let's say, doesn't validate signatures. I don't know, there's a lot of things that you can test. Which of the maintainers' email has a email that is on a domain that is no longer valid and is open for, purchasing, for registering the domain. So a lot of easily accessible public data that can be used in a lot of ways, and for attackers, this is really, really good. Also, you can always take a large list of maintainers, try to get that list over, looking for combo lists of username passwords, and trying to see if you can maybe find some maintainer that reused his password. So, there's an attacker, there's a lot that can be done, and also there's a lot of open source kind of ecosystems that to look for. So just the vast of information that is publicly available is really good for attackers. And also there is a great return on investment for attackers. So let's say you have invested a lot of time, but you will manage to access a fairly popular package maintainer account. That means that you have the ability to get into thousands, hundreds, millions of workstation servers, CI pipelines, if you were to, use that whenever you see right. And also, you have a lot of ways to kind of hide yourself. You can always, at times, unpublish a package. You can always kind of change the code that is fetched from external URLs. You can change it, as you want. So you can add some package which dynamically changes its code according to, I don't know, the IP that it comes from, or timing, or whatever how you see fit on the server side, that holds your static code. So you can maintain yourself unvisible, right? Non-malicious until you want to. Also, there are very little security controls over public registries and malicious packages in public registries. So, that also gives a lot of kind of backwind to attackers. It is true that today there is much more that has been done by public packages repositories, but still it's very lacking, like from other fields that are more mature, kind of security-wise. You can see it just by recent incidents where a single user of NPM is a very good example, because it is very publicly known and used and tested, and has a lot of information. So, and also I code in Node from time to time, but NPM suffered basically a denial of service a few months back, just because he wasn't per se malicious, but he was someone who registered a lot of packages, so it created like an overload. So there was no limits and so on. And again, we're talking about completely anonymous user adding whatever code he wants as many times he wants, and causing real organizations to suffer downtime for their CI, not able to fix bugs. And that's like a very crucial things for NPM just to maintain their, so that's bad for everyone, right? So, and again, they do make some more effort. Some maintainers are required to do 2FA or multiple factors, but and we years ago we would have never dreamed that that would be like a requirement, but today it's not enough. Okay. So that's hackers gonna hack, and supply chain threats. So again, if we look at the OWASP top 10 risks, which is highly regarded as a industry standard for the risks of web security. So we can ask ourselves, where do we see supply chain attacks? So we don't really see it. If I'm giving myself, if I'm giving as much credit as I can probably say that it relates to vulnerable and outdated components. Might be related. It also doesn't have to be outdated or vulnerable. It could be malicious and so on. And so this is like a different kind of threat. And also security logging and monitoring failures. Again, why? Because it relates to that, but it's not the risk, okay? It relates to that because we are lacking a lot of the times in CI logging for data that we need, like did we build this package during this time? So it relates to it, but it doesn't clearly has anything to say specifically about this threat. And I'm positively like my prediction would be that the next and it's pretty close, right? 2025, it's going to be every 4 years, right? So my prediction is it going to be probably a category by itself, like supply chain attack or vector or a confusion attack or whatever, but it will be one of those. And I think it would be pretty also high up as a risk, because it's happening in the wild. We see it, and again, just from the sheer volume of this kind of vector, I think it's going. We won't see it stopping. It's only going to grow, this trend of an attack vector. So just to be a bit more clear about the terms that we use, so there are a few different kind of different risks when we're talking about packages. So one is a malicious public package, which is a malicious code published on a public registry. So this was like the code was born malicious. It never had a single other purpose other this package other than being malicious. Okay, and then there is a rogue public package like ESLint example that I gave, which is a legitimate code that was updated with malicious code, right? Maintainer takeover, account takeover of the GitHub account, of the whatever, or someone just deciding that he's taking his package and making it malicious for whichever purpose. But that's what I call a rogue package, a rogue public package. Next, we have dependency confusion, where in dependency confusion, there is a public package that take precedence over a desired internal package, right? So this is the confusion. It's RCI or one of our pipelines is tricked into getting a malicious package that was added by someone malicious as a public package, and it will take, and since it's the same name, there are certain flows where the public package will take precedence over the internal package, which is meant to be taken, to be to be integrated and built. And then there's a vulnerable package like log4j in the log4shell CVE detected. So this is a non-malicious package, which was found to have a vulnerability. Of course, the log4shell is a very extreme example because we know that it was a very high severity and it was used in the wild to kind of, so we know that a lot of efforts were going there. But generally, when we see any of those kind of threats we suspect any of them, we think any of them happen. So in our own CI, so any one of the first three is an indication for a breach, right? If a malicious code, doesn't matter if it's born malicious, was changed to malicious, or was confused to be taken over a legitimate code, any one of those incidents is basically a breach. You need to treat it like one. You need to check. You need to validate whether or not the code ran in your pipelines. But if it did, and you have indication for that, it means that you might need to rotate all of the keys and all of the assets that are related, affected, including the developer station and other developers that might have ran it, but the developer station that introduced the specific vulnerable code, vulnerable package, right? But in the case of a vulnerable package by itself, the only indication that some vulnerability was introduced by a package, this is by itself not a breach. You can obviously update. You can maybe decide that in some cases you want to check the log to verify that nothing was being used as part of that vulnerability. But this is by itself, a vulnerability is not an indication for a breach. And so it is. This is this is very important. If you need to take one thing, it's probably some of that you cannot fix a breach by updating. You cannot just update a package and say, okay, I fixed it. Unlike a vulnerable package when you can update and say, okay, the vulnerability is no longer there. In those cases, the first three, you need to go and be prepared with an incident response because you are basically you may be breached in a very pretty sure way. If any of these incidents did happen, you need to treat it as a breach, and it's important. Every breach has to have some kind of incident response. You have to assume maybe someone had some of the credentials that are available in those environments where the code is ran, and you need to validate that or rotate and check for any activity according to your own incident response plans. Some don't have incident response plans, and they say, and they rely on external, some organizations rely on external teams. So that also has repercussions. So you might want to have a before you call someone, what do you need to validate? What do you need to check? Maybe you can have enough resources to address the initial triage yourself. So it might be very important. Okay, so if we're looking at what at stake from an incident response view, so let's say you have some indication that you used that malicious package was used inside your CI pipeline or at a developer station, was run, and maybe exfiltrated his FPMRC file or his credentials for the VPN, whatever you suspect. So basically, you need to first triage and see what the indication means, what it relies on, what are the generally, I would always suggest to create a timeline to try to understand, because a lot of the times you can say, okay, for instance, we just got a notification that some package was taken, has been during the last week, has been updated with malicious code, and now it's been known and it's off and whatever. And now we need to say, okay, during this week, have we or have we not built this specific version into an application, into one of our applications? So this might be something that you can answer or not. You need to have logs, you need to know what you're looking for, and you need to maybe look at what would initiate, build. So build could be initiated manually, and they might be initiated by a new merge request, or by a new just just by a commit to a new branch, to any branch, or just commits to a specific branch. So we want to know that that basis, like what is, this is the initial triage to understand whether or not there is anything to follow. And then there is a verdict, basically validate or exonerate. If to exonerate is usually harder, to validate that something is malicious, it's usually easier. But to exonerate, you want to be 100% sure. And then after that, you want to identify the first line of attack of assets at risk. So let's say it's an application, then what is or credentials. So it could be the CI credentials, the environment of the deployment environment, again, where and when and how it was deployed well. And don't forget the developer credentials, its workstation, because today incident response, like I said, as part of the application kind of the application expansion, into a lot of realms. Then today you want to the IT who would check the workstation of the developer, he might be able to check some of the physical forensics for the computer, but it might lack in that does new Git commits were entered as this developer. Like, would he be able to know what he's looking for? Would he know what logs he has in his Git audit that is available for him and what is not? This is usually more in the realm of application security, as they also, a lot of the time, they deal with the different development groups, the different development teams, and their GitHub, the GitHub code owner files. Git code owner files it's usually more in the domains of the application rather IT or something like that. And so all of those kind of checks should be performed for the developers that are related to this incident. Mitigation threat for first line of assets. So this is what you do for the first line of assets in case you define them and you see which of those might need to rotate keys, might need to remove any changes that have been created automatically. So like revert to a specific date, to a specific time. And then you keep on and perform digital forensics for any kind of, you broaden the lines in case there was a movement, some kind of lateral movement within the application, and then that's where you go into like the more the last stage of trying all the time to validate that everything was exonerated and clean. Okay, so again, if we're looking at the challenges for investigative, then this is an example again from npm.js. So packages can be unpublished. So if someone, for instance, if it's something like a dependency confusion attack and someone updated public code, you might be able to remove that code by the time you try to investigate it. So you want to know what that code was doing, unless you have that, and a lot of the time, the indication that something ever happened is that npm removes a package. And when it removes a package, you get the security holding kind of, you get a generic for that version, you get a generic kind of security notice warning, but you can't access the actual code. So for investigators, for the people who do the incident response, they need to understand that this is part of the life cycle. So you might not have access to the particular code, and so it might be harder to investigate. Again, there are some ways you can go at such a challenge. You might be able to, look at mirror repositories that might have it and might not, and might have the latest version or might not. There's a lot of ifs, but all of those you want to kind of think ahead. What I've shown previously is that most of these things, and this can be basically kind of automated, and in the terms of what we have and what we don't have, like identify the line of assets. This could be easy. Usually, what an application, which databases they have access to, and so on. You can do it pre-handed, or you can at least do it once or twice to, like a drill to understand what is missing, what logs are missing. And like this is an example again of something that you pretty easily can find when you start to think about it, as if you're trying to investigate it, and then you find out that that packages can be unpublished and unlisted. And so it makes you think, okay, maybe I need to whatever, like put aside all the code that I download. Maybe I need to have a caching mechanism. Maybe you can find your own answers, I'm sure, but just thinking about premeditating about the challenges that arise, it will save a lot of time. Okay. Also, a few things about the nature of supply chain attacks. So a supply chain attack, it might affect many organizations. Take, for example, Log4j, which is, again, it was an attack in the sense that a known vulnerability was being used in the wild. But any other like ESLint, okay, or something that causes a lot of organizations to kind of wonder if they're related or not. So what it creates is a surge in professional needs, right? A lot of organizations at the same time, let's say Log4j, calls their on-call teams or calls their whoever professional would they advise at these kind of times, and all the advisors are overwhelmed with requests and because everyone is experiencing the same thing. So, if you rely on external professionals, because some people, do, in those kind of attacks, you have to have a bit of more, I think, kind of plan, incident response plan, because it might take a while until you'll be able to be, until you'll be serviced by your professional. But also there is a little a bit of comfort that there's a lot of others that are in the same boat, in the same situation with you, because at scale breaches more time for each of us to kind of individually respond, each organization. Why? Because usually it's not like the data that is was breached, like let's say NPM credentials. It's not at that moment automatically being used to exfiltrate all the data that is available. It's harder than that. Each one is usually can be automatically, except maybe getting all the packages that are there. But if you want to do more, it would probably require more from the side of the attackers, which at the time are being, bombarded with a lot of credentials. So it might work that you can have a bit of more time to, if you need to rotate keys. So in that case, the more the merrier for each, like the risk reduces, because it's a lot of people that are under attack, but still, you don't want to be there. And a breach can be highly targeted or widely spread, right? You have a very similar results. If it's very targeted or widely spread, you have it's still kind of, you end up with the same result of someone might have breached this pipeline, have the credentials that are available by the environment. Let's go from here. So it kind of funnels everything into a very maybe similar incident response, a lot of the scenarios. Also, a dedicated attack is always more likely to escalate quickly because someone is targeting specifically you. For instance, usually because it's name-based, dependency confusion attacks would be more likely to be a dedicated attack. So if you think of generally of dependency confusion, it's usually targeting like naming of specific organization or premeditated knowledge of how, like if the front-end code is exposing names of internal packages. So a dedicated attack, you can be quite sure that it's more dedicated to your specific organization, and then you would want to escalate it quickly. And generally, just a very general sense that a breach cannot get fixed by an update. These are like two separate things. When you want to fix something, and when you want to investigate and potentially have respond to a breach. Okay, completely two different things. Need to remember that. Okay, in my last like 10 minutes, but I want to give some time. I'll go over a bit of our predictions and what you can do, like what is the takeaways and where do we see this field going. So generally, I said it's not going to stop. It's only going to get higher, more and more. I think in being used by hackers in the real world, and of course, I think we will see it that we find more and more kind of usage and targeting applications, pipelines, and developers. We see developers that are being more targeted than ever. Public package managers, I think, will be adding security controls. And more, we already see it, but I think it's going to grow. And because it hurts basically their own their own kind of brand. Okay, their own legitimacy is very well need to be that it is maintainable, that it is safe to use a public package, and I think we're also going to see more and more regulation for supply chain risk management. I think we just, at the start of it, and the more we understand that this field is complex, the more we're going to understand that we need more and more like risk management in this aspect. Okay, and where we think this might be going. So here is some research we did about IDE plugins. So again, why IDE plugins? Because first of all, they're very common, used by any developer. They're open source, like this code is open source. They have open, also IntelliJ, but there's a lot of IDEs. But their usage of extension is a common thing. You probably cannot use any of those for a specific language without using some form of extensions. And then we wanted to see if we can use all of the knowledge that we know about how attackers use, let's say, NPM to kind of confuse developers. Can we do the same for VS Code? So basically, we were able to kind of create an educational package. We were able to use some repository that we have no relations to, very similar to package JSON confusion that was recently disclosed in NPM, or starjacking types of attacks. So we could easily do that and make it appear like our project is very being used. It's very lively. We were also able to add the verified publisher, again, on whichever eligible domain, you can think for yourself. So generally we say okay, this is where we're going to meet. This is one of an example of where you could also expect those kinds of attacks to be happening in the future. And bringing it a bit together. So I think that it is AppSec IR plan is really critical, because it's the biggest growing attack surface. It's a huge return on investment, and it has very unique kind of characteristics, like that when it happens, you might not have proper resources available for you, because it will happen to a lot of people, to a lot of companies. And also it's a bit confusing. It's not our original realm, where we just look at a deployed application, or in process of building an application, saying, okay, what we need to fix. It's something a bit different. And also there are always new tools to allow organization better to handling this threat. But when it comes to incident response, there are still a lot of gaps. And you might want to create and differentiate some of the different threats. So this is an example of what a basic incident response plan can look like. I think you should kind of drill and think of any uniqueness in your organization that would require something, and then go over it and see, do I have like CI logs and SBOM to even start in answering a question like, is a specific malicious package was built or not. Also, the question of failing tests, if for instance, in a dependency confusion, well, it's likely that a public package does not know the logic of the internal package, a test will fail. And in that case, and a failing test is not an indication for, that everything is okay because it wasn't ran to completion, the bill. It's actually a way to indicate that something was wrong, and bad code was maybe ran and caused this entire application not to fail a test. But in the process, it doesn't mean that you're safe. So, you need to take those into account. So again, an example, identify the assets. You need to see if you are lacking there in any way to identify assets that relates to some package, what it does, what's its usage in the code. Maybe it's being built but run without script, so it's safe. Maybe not. So all of that information, including like notify R&D and so on. A lot of the time we see that I've seen that the kind of security goes back and forth with R&D and asking R&D questions. That's not supposed to be like the security in those kind of situations. Probably knows a bit more of the specific risk, and it should create value and not run after R&D. Okay, and that's, I think, basically it. Just know that it was based on 2 different articles that I published. So if you want to read more, the where and how and more about the research that we did, and I'm gonna have 2 more minutes if anyone has any questions. Would be love to hear it. Okay, so if you still might want to ask something, I'm available online, on LinkedIn or whatever. I'm sure you can reach me. So thank you, everyone. The driver behind the Snyk acquisition. So yeah, so I will answer it. So what we did in Enzo and our unique kind of way of thinking was later adopted by a lot of leading vendors, and we talked about ASPM, Application Security Posture Management, meaning we don't care about vulnerability management, but rather the context of what is relevant and what is not relevant, and what will bring the most security, which operation would bring most security. And I think that's what Snyk kind of was looking in their own products to enrich it. They do a lot of good assessment of vulnerabilities, but they were lacking like the bigger context, and that's how they're looking at it now. Like vulnerabilities is just one piece of the puzzle. Other questions? Okay, so with that, thanks everyone, and hope to see you on the other sessions. Bye bye.